March 15, 1944, somewhere in the vast Pacific Ocean, 800 miles southwest of the Marshall Islands. The pre-dawn darkness wrapped around the Japanese submarine I-58 like a shroud as Commander Hashimoto peered through his periscope at what should have been an empty stretch of ocean. Instead, what he saw made him question his own eyes. Through the pale morning mist, massive dark shapes loomed on the horizon like sleeping giants. At first glance, they appeared to be islands that had somehow materialized overnight in waters his charts showed as nothing but deep blue emptiness. But islands do not move, and these colossal structures were definitely moving, cutting through the Pacific swells with the steady rhythm of enormous ships. Hashimoto adjusted his periscope and focused harder on the strange silhouettes. What he witnessed that morning would haunt him for the rest of his life, though he would not fully understand its significance until years after the war ended. The largest of these floating behemoths stretched over 900 feet in length and rose nearly 200 feet above the waterline. Its steel walls formed a perfect rectangle, like a massive concrete building that had somehow learned to swim. Around its edges, smaller vessels buzzed like worker bees attending their queen. Steam rose from multiple points along its deck, and the faint sound of hammering and machinery drifted across the water even at this distance. Most puzzling of all, there appeared to be a ship inside this floating fortress, lifted completely out of the water as if by magic. The submarine commander had stumbled upon one of America's most closely guarded secrets, a technological marvel that would fundamentally change how naval warfare was conducted forever. What Hashimoto was observing through his periscope was the ABSD-1, the first of the advanced base sectional docks, a floating dry dock so massive it could lift a battleship entirely out of the ocean for repairs while thousands of miles from any permanent naval base. The concept was so audacious, so seemingly impossible, that even many American naval officers had initially dismissed it as fantasy when the plans were first proposed. The story of these floating repair cities began 2 years earlier in the cramped offices of the Bureau of Ships in Washington, D.C., where a group of engineers faced an impossible problem. The Pacific theater stretched across thousands of miles of empty ocean, and damaged American warships were spending months sailing back to Pearl Harbor or the West Coast for repairs. During those long journeys home, these vessels were sitting ducks for enemy submarines, and once they reached port, the backlog of damaged ships often meant additional months of waiting. Meanwhile, the Japanese fleet, operating closer to their home bases, could get their ships repaired and back into action much faster. Admiral Ernest King, the chief of naval operations, had grown increasingly frustrated with this logistical nightmare. During one particularly heated meeting in late 1942, he slammed his fist on the conference table and declared that if Muhammad could not come to the mountain, then by God they would bring the mountain to Muhammad. The room fell silent as King outlined his vision for floating shipyards that could be towed anywhere in the Pacific, allowing the American fleet to maintain their ships without ever leaving the combat zone. The engineering challenges seemed insurmountable, but King was not a man who accepted the word impossible. The task fell to a team of civilian engineers and naval architects who worked in secret for months, designing what many considered the most ambitious maritime engineering project since the Panama Canal. The advanced base sectional dock had to be large enough to accommodate battleships and aircraft carriers, yet light enough to be towed across thousands of miles of ocean. It needed to be completely self-sufficient, carrying its own power generators, machine shops, cranes, and living quarters for hundreds of workers. Most critically, it had to be built in sections that could be manufactured at different shipyards and then assembled like a massive floating puzzle at the destination. By early 1943, construction had begun on the first of these maritime giants at shipyards in Mobile, Alabama, and other locations along the Gulf Coast. Each section was a marvel of engineering, weighing thousands of tons yet designed to float and connect seamlessly with its neighbors. The workers building these sections often had no idea what the final structure would look like, knowing only that they were creating something unprecedented for the war effort. Security was so tight that even the welders and riveters were sworn to secrecy about the project they were helping to build. As Commander Hashimoto continued to observe the floating dry dock through his periscope that March morning, he watched American sailors moving about the deck with the casual efficiency of men who had already grown accustomed to this miracle of engineering. Inside the dock, a heavy cruiser sat high and dry, its hull gleaming wet in the morning sun, while teams of workers swarmed over it like ants. Sparks flew from welding torches, and the sound of pneumatic hammers echoed across the water. What should have taken months of dangerous travel and dock time back in California was happening right here in the middle of the Pacific, turning what had once been America's greatest disadvantage into their secret weapon. The massive steel sections that would become America's floating repair cities began their journey in the most unlikely of places. The muddy shipyards of Mobile Bay, where Spanish moss hung from ancient oak trees, and the humid Alabama air buzzed with mosquitoes and the constant ring of hammers on steel. Workers arrived each morning at dawn, their lunch pails in hand, completely unaware that they were building pieces of what would become the largest movable structures ever created by human hands. The project was so secret that even the foremen only knew they were constructing massive steel boxes with precise measurements that had to match perfectly with other sections being built hundreds of miles away. Each section of what would become the advanced base sectional dock weighed over 3,000 tons and measured roughly 90 feet in length. When welders like Charlie Morrison from Tuscaloosa finished their shifts, they would head home to their families with no idea that the steel walls they had just assembled would soon be floating in the middle of the Pacific Ocean, holding damaged warships high above the waves. Morrison later recalled in his diary how strange it felt to build something so massive that seemed to serve no obvious purpose. The workers joked among themselves that maybe they were building swimming pools for giants or storage containers for Paul Bunyan, but the military guards who watched every move made it clear that questions were not welcome. The engineering challenges of creating a floating dry dock were staggering beyond imagination. Traditional dry docks were built into the ground, using the solid earth itself to support the massive weight of ships being lifted from the water. But a floating version had to support that same weight while remaining stable on the constantly moving surface of the ocean. The steel walls had to be strong enough to hold millions of gallons of water, yet light enough to float when empty. Even more complicated, the entire structure had to be designed so that when sections were flooded with water, the dock would sink down into the ocean, allowing a damaged ship to float inside, and then when the water was pumped out, the dock would rise back up, lifting the ship completely clear of the waves. The genius behind this seemingly impossible feat was a civilian engineer named Captain John Laycock, who had spent his career designing bridges and had never worked on a ship in his life. Laycock approached the floating dry dock problem the same way he would design a suspension bridge, thinking about weight distribution, stress points, and structural integrity. His breakthrough came during a sleepless night in December 1942 when he realized that the dock did not need to be one solid piece, but could be built in sections that would share the load between them. Each section would have its own pumping system and ballast tanks, so if one section was damaged, the others could continue operating. By spring 1943, sections of the first advanced base sectional dock were being loaded onto transport ships for the long journey across the Atlantic, through the Panama Canal, and into the Pacific. The logistics of moving these enormous steel boxes were almost as complicated as building them had been. Each section had to be carefully positioned on specially modified cargo ships, and the route had to be planned to avoid German U-boats in the Atlantic and Japanese submarines in the Pacific. The convoy carrying ABSD one took nearly 2 months to reach its destination at Espiritu Santo in the New Hebrides, where teams of Seabees waited to begin the delicate process of assembly. The assembly of the floating dry dock was like putting together the world's largest and most expensive jigsaw puzzle, except that each piece weighed thousands of tons and a single mistake could sink the entire project. Chief Petty Officer Mike Sullivan, who supervised the assembly crew, described the process as the most nerve-wracking job of his naval career. The sections had to be positioned precisely and then welded together underwater by divers working in the murky tropical waters of the harbor. One small error in alignment, and the sections would never fit together properly. The welding alone took weeks, as each joint had to be perfect to prevent leaks that could sink the entire structure. When the first test came in August 1943, hundreds of sailors and construction workers lined the shores of Espiritu Santo Harbor to watch the massive structure attempt its first lifting operation. A damaged destroyer escort, the USS Fleming, had volunteered to be the guinea pig for this unprecedented experiment. As the ballast tanks were slowly pumped out and the dock began to rise from the water, sailors held their breath and watched in amazement as the Fleming gradually emerged from the ocean like some kind of maritime magic trick. The ship that had been floating normally just minutes before was suddenly sitting high and dry on the deck of the floating dock, its hull completely exposed to the tropical sun. The success of that first test sent ripples of excitement through the Pacific Fleet Command. Admiral Chester Nimitz himself flew out to inspect the floating dry dock and declared it one of the most important innovations of the war. Within hours of his visit, orders went out for the construction of additional advanced base sectional docks, and plans were made to position them at strategic points throughout the Pacific theater. What had started as an impossible dream in a Washington conference room was now a reality that would change the course of the naval war against Japan. The news that American ships could now be repaired in the middle of the Pacific Ocean spread through Japanese naval intelligence like wildfire, but the reports were so unbelievable that most commanders dismissed them as Allied propaganda designed to confuse and demoralize their forces. Admiral Isoroku Yamamoto, the architect of the Pearl Harbor attack, received the first detailed intelligence report about the floating dry docks in September 1943 while aboard his flagship anchored in Truk Lagoon. The report came from a submarine captain who claimed to have observed American warships being lifted completely out of the water by massive floating structures that appeared to be mobile shipyards. Yamamoto read the report twice, then set it aside with a shake of his head, convinced that his submarine commander had been at sea too long and was beginning to see mirages. The Japanese High Command had built their entire Pacific strategy around the assumption that geography was their greatest ally in the war against America. The vast distances of the Pacific Ocean meant that damaged American ships would have to make the long, dangerous journey back to Pearl Harbor or the West Coast for repairs, effectively removing them from combat for months at a time. Japanese war planners had calculated that this logistical disadvantage would eventually force the Americans to seek a negotiated peace rather than continue fighting a war across such enormous distances. The idea that the Americans could simply bring their shipyards to the battle zone was so far outside Japanese military thinking that it seemed like science fiction rather than strategic reality. Lieutenant Commander Kazuo Sakamaki, one of Japan's most experienced intelligence officers, was tasked with investigating these impossible reports of floating dry docks. Sakamaki had studied at Harvard before the war and understood American industrial capacity better than most of his colleagues. But even he struggled to believe that the United States could build structures large enough to lift battleships out of the ocean and then tow them thousands of miles across the Pacific. His investigation began with interrogating captured American sailors, but their accounts only deepened the mystery. Pilot William Hayes, shot down during a raid on Rabaul and taken prisoner in October 1943, told his captors about seeing what he called floating cities scattered across the Pacific, each one capable of repairing multiple ships simultaneously. The first undeniable proof came in November 1943 when reconnaissance photographs taken by a Japanese scout plane clearly showed the massive Advanced Base Sectional Dock ABSD-2 at Manus Island in the Admiralty Islands. The photographs revealed a structure so large it dwarfed the heavy cruiser USS Portland that was sitting inside it, completely out of the water. Japanese photo interpreters spent days studying the images, measuring the dimensions of the floating dock, and trying to understand how such a massive structure could possibly remain stable while lifting a 10,000-ton warship high above the ocean waves. The engineering implications were staggering, and the strategic consequences even more so. What the Japanese did not realize was that the Americans had not just built one or two of these floating marvels, but were mass-producing them with the same industrial efficiency that had made American factories the envy of the world. By early 1944, 6 advanced base sectional docks were operating throughout the Pacific theater, and more were being assembled every month. Each dock was essentially a complete shipyard that could be towed anywhere the Navy needed it, turning remote coral atolls into major repair facilities overnight. The USS Intrepid, badly damaged by a kamikaze attack off the Philippines, was repaired to fighting condition in just 12 days at a floating dry dock near Ulithi Atoll, a repair job that would have taken months at Pearl Harbor and required the carrier to miss several major battles. The psychological impact on Japanese forces was perhaps even more devastating than the strategic advantage these floating shipyards provided to the American fleet. Japanese sailors began reporting sightings of American ships that they were certain had been sunk or heavily damaged in previous battles, yet here they were again, apparently fully repaired and ready for combat. The cruiser USS Birmingham had been severely damaged by a magazine explosion in October 1944 that killed over 200 sailors and left the ship barely able to stay afloat. Japanese intelligence marked the Birmingham as effectively destroyed and out of the war, yet just 6 weeks later, the same ship was spotted leading a task force attack on Japanese positions in the Philippines, looking as if it had just rolled out of a shipyard. The floating dry docks also allowed the American fleet to establish forward bases in locations that would have been impossible to supply with traditional repair facilities. Ulithi Atoll, a remote collection of coral islands in the Caroline chain, became one of the largest naval bases in the world almost overnight when several advanced base sectional docks were positioned in its protected lagoon. What had been an empty stretch of tropical paradise became a bustling repair and resupply center that could service the entire Pacific Fleet without requiring ships to return to Pearl Harbor. Japanese reconnaissance flights over Ulithi revealed a sight that must have seemed like a nightmare to enemy commanders, with dozens of American warships receiving repairs and maintenance just 1,000 miles from the Japanese home islands. The strategic revolution was complete, and the Japanese high command finally began to understand the true magnitude of what they were facing. The Americans had not just built a better mousetrap, they had fundamentally changed the rules of naval warfare itself, turning the vast Pacific from Japan's protective barrier into America's highway to victory. The daily life aboard one of America's floating repair cities was unlike anything any sailor had ever experienced, combining the industrial chaos of a major shipyard with the constant motion and isolation of life at sea. Chief machinist mate Robert "Red" Murphy from Detroit had worked in the Ford River Rouge plant before the war, but nothing had prepared him for the surreal experience of operating a complete machine shop while floating in the middle of the Pacific Ocean. Murphy's workshop aboard ABSD, 3 contained lathes, milling machines, and welding equipment that could fabricate replacement parts for everything from torpedo tubes to aircraft engines, all while the massive floating dock swayed gently in the tropical swells. The sound of machinery never stopped, day or night, as teams of workers labored around the clock to keep the American fleet in fighting condition. The men who worked on these floating dry docks came from every corner of American industry, brought together by the common goal of keeping ships fighting rather than sailing thousands of miles back to the States for repairs. Tommy Kowalski had been a plumber in Chicago before the Navy assigned him to ABSD-4, where his skills were put to use maintaining the complex system of pumps and pipes that allowed the massive structure to sink and rise with mathematical precision. Kowalski would later write to his wife that working on the floating dock was like being inside a giant mechanical whale that could swallow ships whole and then spit them out better than new. The complexity of the pumping system was staggering, with thousands of valves and controls that had to work in perfect coordination to safely lift and lower vessels weighing tens of thousands of tons. One of the most remarkable aspects of life on the floating dry docks was the incredible efficiency that developed as crews learned to work together in this unique environment. When the heavy cruiser USS Pensacola limped into the floating repair facility at Manus Island in March 1944 with severe battle damage from a night engagement with Japanese destroyers, the dock crew had her lifted out of the water and under repair within 6 hours of her arrival. Damage that would normally require months of work in a stateside shipyard was completed in just 18 days, thanks to the focused effort of specialists who had nothing else to do but concentrate on their repairs. The Pensacola's captain, James Dorn, recorded in his log that he had never seen such dedicated and skilled work, noting that the floating dock crew treated every repair job as if the outcome of the entire war depended on their success. The floating dry docks also served as massive supply depots, carrying enough spare parts, ammunition, and provisions to support an entire fleet for months at a time. The The storage compartments within ABSD. 2 contained everything from replacement radar equipment to thousands of gallons of ice cream mix, because Navy planners understood that maintaining morale was just as important as maintaining machinery. Seaman First Class Danny Martinez from San Antonio spent his days managing the food storage areas aboard the floating dock, ensuring that ships taking on supplies could get everything from fresh vegetables to holiday turkeys, even while anchored thousands of miles from the nearest land. Martinez often marveled at the fact that he was essentially running a floating grocery store the size of several city blocks, serving customers who happened to be some of the most powerful warships ever built. The medical facilities on the advanced base sectional docks rivaled those of many stateside hospitals, complete with operating rooms, X-ray equipment, and recovery wards that could handle hundreds of wounded sailors and Marines. Dr. Sarah Mitchell, one of the few women stationed on the floating repair facilities, had volunteered for duty in the Pacific after finishing her residency at Johns Hopkins Hospital. She found herself performing emergency surgery under conditions that would have been impossible in a traditional hospital, operating on wounded sailors while the floating dock rolled gently in 6-foot swells, and the sound of welding torches echoed through the steel corridors. Dr. Mitchell's surgical team saved hundreds of lives that would have been lost during the long journey back to Pearl Harbor, proving that the floating dry docks were not just ship repair facilities, but complete forward medical bases as well. Perhaps the most impressive demonstration of the floating dry docks capabilities came in June 1944, when the aircraft carrier USS Franklin arrived at ABSD, 6 after suffering catastrophic damage from a Japanese kamikaze attack. The Franklin's flight deck had been completely destroyed, her superstructure was twisted wreckage, and fires had gutted much of her interior spaces. Traditional naval wisdom would have declared the carrier a total loss, suitable only for scrap metal, but the floating dock crew saw her as their greatest challenge yet. Working in shifts around the clock for nearly 2 months, they essentially rebuilt the Franklin from the inside out, replacing her flight deck, reconstructing her island superstructure, and installing new equipment that was actually more advanced than what she had carried originally. When the Franklin left the floating dry dock in August 1944, she was arguably a better ship than when she had first been commissioned. The success of these floating repair operations sent shockwaves through the Japanese high command, who were forced to confront the reality that American industrial might could now be projected anywhere in the Pacific Ocean. What had once been Japan's greatest strategic advantage, the vast distances that separated American forces from their supply bases, had been completely neutralized by these mobile shipyards that brought American industrial capacity directly to the front lines of the naval war. The Japanese response to America's floating dry docks was swift and desperate, marking a fundamental shift in their naval strategy from offensive operations to increasingly frantic attempts to neutralize what they now recognized as a war-winning advantage. Admiral Somu Toyota, who had replaced the late Admiral Yamamoto as commander of the combined fleet, convened an emergency meeting of his staff in Tokyo during the first week of December 1944 to address what intelligence reports were calling the American floating shipyard threat. The room fell silent as Toyota spread reconnaissance photographs across the conference table, showing massive steel structures scattered across the Pacific like stepping stones leading directly to Japan's doorstep. Each photograph represented not just a repair facility, but a strategic nightmare that was allowing the American fleet to operate with an endurance and resilience that Japanese planners had never imagined possible. The first attempts to destroy the floating dry docks came from Japan's submarine fleet, which had been struggling throughout 1944 as American anti-submarine warfare became increasingly effective. Commander Tadeo Kato, captain of the submarine I-401, received orders in January 1945 to locate and sink the advanced base sectional dock that intelligence reports placed somewhere near Ulithi Atoll. Kato's mission was considered so important that his submarine was equipped with special long-range torpedoes and additional fuel supplies for an extended patrol. For 3 weeks, I-401 prowled the waters around Ulithi, but the floating dry dock was so heavily protected by destroyer escorts and patrol aircraft that Kato never managed to get within striking distance. His closest approach came on a moonless night when he surfaced just long enough to observe the massive structure through his periscope, its deck blazing with work lights as American crews labored through the night to repair damaged ships. Cato later described the sight as both magnificent and terrifying, a floating city of American industrial might that seemed to mock Japan's increasingly desperate situation. As submarine attacks proved ineffective against the heavily guarded floating repair facilities, Japanese planners turned to their newest and most desperate weapon, the kamikaze corps. The special attack units had been originally conceived as a way to inflict maximum damage on American aircraft carriers and battleships, but by early 1945, target priorities had shifted to include the floating dry docks that were keeping those same ships in fighting condition. Lieutenant Yukio Seiki, one of the most experienced kamikaze pilots, was briefed on a mission to attack ABSD-4, which had been spotted near Leyte Gulf conducting repairs on several damaged American cruisers. Seiki's briefing included detailed drawings of the floating dock structure, with emphasis on the massive ballast tanks that kept the facility afloat. If those tanks could be ruptured, intelligence officers explained, the entire structure might sink with any ships it was currently servicing. The kamikaze attack on ABSD-4 came on the morning of February 14, 1945, when 6 Japanese aircraft approached the floating dry dock at wave-top level, hoping to avoid radar detection until the last possible moment. The attack was partially successful, with 2 planes managing to crash into the dock's superstructure before being shot down by defending gunners. The explosions killed 17 American sailors and caused significant damage to the dock's crane systems, but the massive structure remained afloat and operational. Within hours of the attack, repair crews were working to fix the damage, and by the following morning, the floating dry dock was back to full operation. The resilience of these floating fortresses seemed to defy every attempt to destroy them, leading one frustrated Japanese naval officer to comment that attacking the American floating docks was like trying to sink a mountain. The most ambitious Japanese plan to neutralize the floating dry dock threat came in March 1945 with Operation Tengo, a desperate scheme that called for the super battleship Yamato to break through American defenses and attack the concentration of floating repair facilities at Ulithi Atoll. The plan was essentially a suicide mission, with the Yamato and her escort ships expected to fight their way to the target and inflict as much damage as possible before being destroyed by overwhelming American forces. Admiral Seiichi Ito, who commanded the Yamato Task Force, understood that his ships were sailing to their doom, but Japanese planners believed that destroying even 1 or 2 of the floating dry docks would be worth the sacrifice of their most powerful remaining warship. The Yamato never reached her target, intercepted and sunk by American aircraft on April 7, 1945, while still hundreds of miles from Ulithi. Her destruction marked the effective end of Japanese attempts to neutralize the floating dry dock threat through conventional naval action. By this point in the war, the advanced base sectional docks had become so numerous and so well protected that attacking them required resources Japan no longer possessed. Intelligence reports in April 1945 identified 12 different floating dry docks operating throughout the Pacific Theater, each one representing a level of American industrial and logistical capability that Japan could not hope to match. The psychological impact of the floating dry docks on Japanese morale was perhaps even more devastating than their strategic effect on naval operations. Japanese sailors began to speak in hushed tones about the American ghost ships that seemed to return from the dead, vessels they were certain had been sunk or crippled in previous battles, yet reappeared weeks later looking better than new. The knowledge that America could repair and refit their entire fleet without ever leaving the combat zone drove home the hopelessness of Japan's position in a way that no amount of battlefield defeats had managed to accomplish.